why Kubeflow? In today's video, we will deep dive into one of the best MLOps platforms, that is Kubeflow. So you will learn what is Kubeflow, why Kubeflow, how it helps in ML workflow and MLOps. You will also learn what are the different components of Kubeflow. Especially, we will deep dive into one of the important components of Kubeflow, that is Kubeflow pipelines. Then I'll also show you how to install Kubeflow pipelines, how to write your very first Kubeflow pipeline by taking a hello world example. And then we will deep dive into a real world example using Kubeflow pipelines. So we will take a real world model and try to understand Kubeflow pipelines better. This video is going to be very interesting. Make sure you watch it till the end. Even if you don't have any prior understanding of Kubeflow, or if you don't have any prior understanding of MLOps even, trust me, by the end of this video, you will find it significantly beneficial. I also have complete notes that is required. So whatever commands that I execute, I will share a GitHub repository in the description. By following the same, you can also perform the demonstration. So without wasting any time, let's get started. First things first, what exactly is Kubeflow? So to understand that, let's go a step back and start with understanding what is machine learning lifecycle. So just like traditional software development lifecycle, so to build an application, there are various stages that are involved, or to ship an application to production, there are multiple stages that are involved in traditional software development lifecycle. For example, let's say you're building an e-commerce application. Initially, planning is required, then requirement gathering and analysis of the requirement is required, then high-level design and low-level design. After that, developers work on implementation, which is developing the application and also maybe writing some build scripts. Then the application has to be tested, then the application has to be deployed, and finally, application has to be constantly monitored. And this is not a one-time process. This is a very iterative process. That means maybe after the initial planning, a new feature request might come from your client or maybe from the business. So whenever there is a new feature request or even when there is a bug, probably a new high-level and low-level design is required. Again, developers work on the implementation, build, testing, deployment, and monitoring of the application. So because this is a quite iterative process, DevOps came into picture. Because if every time developers have to manually do this entire process, it takes a lot of time for them. So DevOps is something that aims at unifying development and operations. In simple words, DevOps is something that tries to eliminate the operations effort. So for that, DevOps engineers introduce various platforms or various tools at different stages of software development lifecycle. For example, during the build stage, DevOps engineers might come up with the build tools like Maven or Gradle, depending upon the programming language. Even for deployment, DevOps engineers come up with continuous delivery. For testing, continuous testing. For monitoring, DevOps engineers comes up with observability platforms. So not only CI/CD, but at different stages, DevOps engineers introduce different tools to reduce the manual effort that is involved in software development lifecycle. So this way, application, maybe if there is no DevOps, if it goes to production in, let's say, 3 months, or for every feature, let's say the production time is 3 months. With DevOps, the production time might come down to 1 month. And the entire process is quite effective without any manual intervention. Now, if there is software development lifecycle involved for traditional application development, there should be something for model development as well. Or there should be something for machine learning as well. Exactly that is where machine learning lifecycle comes into picture. So just like software development, when model development is required, or when a company is working on a new model, there are various stages. First one is problem definition, just like you're planning. But here, what kind of model are you working on? What exactly is the problem statement? Maybe weather forecast, right? Or maybe predicting if a patient has diabetes. So first, problem definition or problem statement is the first stage of machine learning lifecycle. Now, depending upon the problem statement, the machine learning engineers work on developing the model, identifying the exact machine learning algorithm, etc. Then for any model or even for ML and AI, data is very, very critical. Let's say your model has to predict weather or it has to predict climate of a particular place. It needs huge amount of data. At least it needs the data for the last 30 years, for the last 40 years, so that your model can be trained on the data and it can give you accurate results. So more the amount of data, more is the accuracy of machine learning models. So that's why data, which is relevant to the problem that you're solving, needs to be collected. Of course, this data will be in quite unorganized format. So then the data analysis and data serialization is important. And then what kind of feature engineering? Probably, you will keep working on different features. You might not develop the model in one single go. It will be an iterative approach. So feature engineering is involved, or you can call it as development that is involved. Then the model has to be trained with the data. In this stage, you might identify the algorithm that is required, right? Once you identify the algorithm, such as random forest or isolation forest, whatever it is, Then the model has to be trained with the data. Now, once the training is done, the model has to be evaluated, because your machine learning model, it might have 60% accuracy, it might have 80% accuracy, or it might have 99.9% accuracy. Imagine you go to a hospital and you get a report or a scan done. Now you give this scan to a machine learning model. So a company has developed this model. What it does, it looks at your X-ray scan and it tells you what exactly is your problem. Or maybe it tells you if you have a fracture or there is no fracture involved. So this machine learning model, it will be trained on data. So maybe hundreds of thousands of images, X-ray images, it will be scanned on. And depending upon how better model is developed, accuracy will be based on that. Of course, it will be based on machine learning algorithm. It will be based on how well it is trained and also how much data you provide to the model. Now imagine if this has only 60% accuracy, then that's a big problem, because you cannot use it at least to your patients. Because if the model accuracy is low, that means there are high chances, even if the patient does not have a fracture, but still your machine learning model says, okay, there is a fracture. So that's why model has to be constantly evaluated and it has to be tuned. Then the model has to be deployed so that people can access it. Maybe during the deployment, you package it with a software application and maybe you deploy it as a website or as part of a website. And finally, monitoring of the model. And during monitoring of the model, a retraining of the model is also required, because as there is new data that is coming in, model's efficiency usually goes down from 99%. Whenever new data is added, your model efficiency might come down to 90%. So again, your model has to be trained with the new data. Again, your model has to be evaluated, your model has to be tuned, and your model has to be deployed. So just like software development lifecycle, this is also an iterative approach. And even when you compare with software development lifecycle, machine learning lifecycle is very, very iterative approach. That's one of the main reasons why a lot of machine learning engineers, they have the model on their laptop, but they don't ship it to the production. And a study says almost 80% of the models, they are buried in the laptops of the ML engineers, but they haven't reached the production because of the same problem. Initially the efficiency of the model might be high, but every time as the data keeps coming in, the efficiency keeps going low. Or every time there is a feature requirement, the efficiency of the model keeps going down. Now, how can someone help with this iterative approach? So taking DevOps as an inspiration, MLOps came into existence. What MLOps does? It does the same thing as DevOps. Now, if you understand what exactly DevOps does, MLOps is an extension and it is related to machine learning lifecycle. At each stage of machine learning lifecycle, wherever operations is involved or wherever a lot of manual effort is involved, MLOps, let's say MLOps platform or MLOps engineers introduce tools or introduce components to solve that particular operations effort. Let's talk about data loading, or let's talk about data analysis or model training. Imagine if there is a tool that improves the efficiency or significantly reduces time that is taken versus someone who is doing it manually, right? Just like CI/CD for DevOps engineers, if there is CI/CD for ML workflow, wouldn't that be awesome? And that is what MLOps does. Of course, it's beyond CI/CD. Just like how DevOps is beyond CI/CD, DevOps is also monitoring, DevOps is also constantly observing the state of the application. Similarly, MLOps is also CI/CD for ML workflows, plus monitoring of the models, plus tuning of the models, everything that is required to reduce the operations effort. Now, what is MLOps? MLOps is machine learning operations. What MLOps does? It unifies or it bridges the gap between machine learning and operations that is involved in traditional machine learning lifecycle. But Abhishek, do I need to learn various tools, just like how I learn various tools as part of DevOps? Do we need to learn various tools to learn MLOps and to implement MLOps for a company? Definitely, the answer is yes and no. Because when it comes to MLOps, there are standalone platforms. What we are going to learn today, a standalone MLOps platform, that is Kubeflow. Or you can deal with individual sets of tools. Either you can add, if you're working as a MLOps engineer, either you can add a tool at every stage of your machine learning lifecycle, or you can go with a comprehensive or standalone platforms like Kubeflow or MLflow. Of course, MLflow is out of context for today's video, but just understand it is another platform that also helps at solving the same problem. However, Kubeflow is more sophisticated platform. So it comes with more robustness when compared to MLflow. Now, Kubeflow, as I told you, is not a single tool or it's not a single project. Basically, it's a collection of components, right? So within Kubeflow, there are various components. So it's a combination of projects where each of the component aims at solving the operations involved in machine learning lifecycle. Now, if we go back and talk about stage by stage, we were talking about loading of the data, right? For loading of data, you can use a component of Kubeflow, which is Kubeflow pipeline. So Kubeflow pipeline can help you with loading of data. It can also help you with, to some extent, training of the data, right? And then there is Kserve, which can help you with deployment, model deployment, and exposing it to external world. There is Kubeflow notebooks, which is useful for execution. So usually ML engineers, whenever they write the Python script, they use Kubeflow notebooks or Jupyter notebooks, and it is very easy for them to evaluate step by step or execute part of the programs. Then there is KATIB. KATIB is used for hyper tuning of the model. Don't worry, we will understand step by step. KATIB is used for hyper tuning of the model. Then there is model registry. I'm sure you all know what is a model registry. Just like how you have traditional application registry or a container registry, similarly you have something called model registry. Overall, you have the Kubeflow dashboard, which is serving as UI, user interface for the complete Kubeflow project. If you consider all of these projects under one roof, that is Kubeflow, Kubeflow dashboard helps you with the user interface. Just like how you have AWS, within AWS you have multiple services, whereas you have a single dashboard or user interface for AWS. Right? To access EC2 or to access S3 bucket, you use the AWS user interface. Similarly, to access these projects, you have Kubeflow dashboard. Now, just to repeat, as you have seen, there are multiple stages involved in machine learning lifecycle. So for data collection or loading of the data, Kubeflow pipelines, let's call it as KPF. It is actually called as KPF very shortly, right? So there is something called KPF in the short notation of Kubeflow pipelines. Then data analysis, and when it comes to feature engineering and selection. So for the feature engineering and selection, the Jupyter notebooks or Kubeflow notebooks can be used. For training, Kubeflow pipeline can be used, which is a component of Kubeflow. Along with that, there is also a training operator. So within Kubeflow, there is also a component called training operator that can also be used. For model evaluation, again, Kubeflow is very good, and you have Kubeflow pipelines for the same to evaluate the efficiency of your model. For model deployment, there is Kserve. And for monitoring of the model, you can integrate Kserve with observability platforms like Prometheus, Grafana, or any other popular observability platforms. So this way, Kubeflow has components for each stage of machine learning lifecycle. Right? So Kubeflow is an end-to-end MLOps platform. Now, Abhishek, do I have to learn Kubeflow project altogether? Like, can I learn individual component? Yes. And that is the best approach to learn Kubeflow. Like, instead of diving into all of the components at once, because when you're learning DevOps, you don't learn DevOps altogether. You learn build, you learn deployment, you learn CI/CD as different components. Similarly, even when it comes to MLOps, do not learn it all together. You will find it overwhelming. Instead, if you're learning Kubeflow, learn it component by component. And the most important component is Kubeflow pipelines. Why? Why is KFE, which is Kubeflow pipelines, very important? Because it can help you with, it is just like CI/CD for DevOps, and it can help you with data loading, right? It can help you with training of the data or training of the model. It can also help you with evaluation of your model, right? So when you provide your model or when you run it as a pipeline, so it can perform all of these things. When we try with an example, you will understand. Like we have two examples in today's video. One is Hello World and one is a model. So then you will realize how KFP solves different stages of the machine learning lifecycle. So go component by component. And the best part is that Kubeflow allows you to do that. Either you can install the entire Kubeflow at once, or if your company don't want to use, let's say, Kserve, or if your company is not interested in using Kubeflow training operator, or maybe Kubeflow notebooks, you can also go and install one of the component standalone. That is what we are going to do now. We will install Kubeflow pipelines as a standalone solution. You have a very good documentation. Don't waste your time going to different sources of documentation or visiting different websites, because within the Kubeflow documentation, you have perfect installation steps. If you want to install Kubeflow altogether, you can just go to getting started and installing Kubeflow. Or if you want to go with a particular component of Kubeflow, so instead of installing it as a whole thing, go to Kubeflow projects, select the project that you're interested in. Do you want to install KATIB? Do you want to install model registry? Do you want to go for Kubeflow trainer? We want to go with Kubeflow pipelines. And within this, just go to operator guide and click on the installation section. That's it, you're good enough. But Abhishek, I want to install the entire Kubeflow. There is something called Miniserve, MiniKF, my bad. So MiniKF is a solution that can help you, just like Minikube, it's a solution that can install Kubeflow on your laptop. However, it only works better on Windows. As per my recommendation, go step by step. So we will start with Kubeflow pipelines. Now to install Kubeflow, you need a Kubernetes cluster. But Abhishek, why do I need a Kubernetes cluster for this? Like, the thing is, Kubeflow is a solution that is very tightly coupled with Kubernetes. And the goal of Kubeflow, or the whole purpose of Kubeflow, is also to implement the machine learning lifecycle on a Kubernetes cluster. So when we are writing the Kubeflow pipelines, as I told you, which is just like CI/CD, each and every stage that you're writing, it can be loading of data, it can be training of data, or it can be evaluation of data. They actually run as containers or pods within your Kubernetes cluster. So Kubeflow is very tightly coupled with Kubernetes. And the name also says that, right? Kubeflow. So you are implementing machine learning lifecycle on a Kubernetes cluster. So we need a Kubernetes cluster for it. Very simple. Whether you have a Windows machine, whether you have a Linux machine, or even a Mac OS, all that you need to do is go for Kind. Kind can help you run Kubernetes cluster in minutes. You need Docker Desktop for it. So on your laptop, install Docker or Docker Desktop. So I have Docker running. Let me recheck. Okay, so I will try to run Docker PS, Docker images. Perfect. So I have Docker running on my machine. Now what is the second step? Second step is you need to install Kind. But Abhishek, where do I find these steps? As I told you, I have prepared a GitHub repository for you. So this is the GitHub gist file. It's not a repo, it's a gist file. So within this GitHub gist, you have the installation guide and also the pipelines that we're going to run. Okay. So in the installation, first step is to install Docker Desktop. Second step is to install Kind. If you're not sure where to install Kind from, just click on this link, select your operating system, and as per your operating system, go ahead and install Kind. Again, I have Kind running on my machine. Kind get cluster. There are no clusters, but that's okay. We'll create a cluster. If you're not sure about Kind, if you're completely new, I have a complete tutorial on Kind. I will try to put that description as well. Kind create cluster -- name is equals to KFP demo YT. Okay, so I'm creating a cluster KFP, which is a shorthand for Kubeflow pipelines. We should have a cluster in less than a minute. Perfect. So kubectl get nodes. Okay, so kubectl is connected to the same cluster. We are all good. Now, just go to the documentation. You can also go to Kubeflow official documentation. Deploy the Kubeflow pipelines. These are the commands that you need to run. Now, what exactly are these commands doing? First, the version of the Kubeflow pipeline. We are exporting a variable and we are applying the configuration to install custom resource definitions or CRDs that are related to Kubeflow pipelines. As I told you, Kubeflow is tightly coupled with Kubernetes. So end of the day, you write a Python script, you load that Python script, and using the Kubeflow package, Python package, you compile that to a YAML file, right? So what exactly we do with Kubeflow? First, we write a Python script, or developers write a Python script, ML engineers. Then there is a Python package called KFP, same thing, Kubeflow pipelines. So you install this using pip. What this KFP does? So KFP compiles your Python script to a YAML file, and this YAML file is submitted to the Kubernetes cluster. And when it is submitted to the Kubernetes cluster, this Kubernetes cluster runs containers or it runs pods, right? For each stage of your Kubeflow pipeline. So let's say you have 3 stages, one for loading of data, one for training of data, one for evaluation of the model performance, then 3 containers, or at least for loading and training, 2 containers or 2 pods get triggered on your Kubernetes cluster. So it's a complete cloud native thing. Just like if you're using GitHub Actions, how for each stage of your pipeline or each stage of your workflow, how there is a virtual machine that is created, and within the virtual machine, how you have your workflow running or your actions running within the virtual machine. Similarly, when it comes to Kubeflow, containers are run within the Kubernetes cluster. Your Python script is compiled to the YAML file using the KFP module. We will do all of it. Okay, going back. So this installs CRDs, and then it will wait for the CRDs for 60 seconds. And finally, this particular kubectl apply, it will install all the pods related to Kubeflow pipelines. This entire thing will take 3 minutes of time. So please wait for it to complete. And also there is a very important note in the Kubeflow documentation. For some reason, if this does not go well on your laptop, so there are cases that it doesn't work on specific Mac OS or it doesn't work on Windows. So what you need to do is just delete the pods that are created and then just run the platform agnostic kubectl command. So instead of this command, you just need to run this command. The first CRD command will stay intact. Only thing that will change, instead of this one, run this. Personally, I also ran into this issue and I have also commented on the Kubeflow GitHub repository. So I noticed there is a bug that is open. I also commented my findings. If I have time, I'll also create a pull request for the same. Going back. Okay. So let's see. kubectl get pods hyphen n kubeflow. Okay. Containers are creating. An interesting thing to note, if you're wondering, Abhishek, which CI/CD platform or which CI solution kubeflow use under the hood, it is actually Argo workflows. So the controller that you see here, workflow controller, is Argo workflow controller. Okay. So all the pods are in the running state. Now let's go ahead and access kubeflow pipeline dashboard. So we will access KFP dashboard from the browser. To do that, all that we need to do is port forward the ML pipeline UI. So again, this is one of the pod. This is one of the service. So we will just port forward the service so that we can access it from our browser. So on the terminal, I will fire this command. Once port forwarding is enabled, I can access it on localhost 8080. Okay, localhost 8080. Perfect. So we have the kubeflow pipeline dashboard here. So we have done the installation. What have we learned till now? Very quickly. So we learned what is kubeflow. We learned why kubeflow. We learned about ML workflow and ML ops. We learned about different components of kubeflow. We will go ahead and write our kubeflow pipeline, very first one, but we learned how to install kubeflow pipeline as well. Cool. So now we have the dashboard. So let's see how to write the pipeline. The interesting part here, as I just mentioned sometime back, when it comes to kubeflow pipelines, we will not actually write the YAML file, but we will use the same Python program. So when developers are working on developing the model, so they must have written a Python script or they must have written a Python program. We will use the same Python program. We will use something called DSL, which is domain specific language. And we will compile this Python file to a YAML file. If you are thinking this is difficult, to be very honest, this is very, very simple because you don't even have to write the YAML file. Python file is written by the ML engineers. You just need to add DSL. But Abhishek, what do we need to add with respect to DSL? I will show you. There are some pre-built functions. There are some pre-built annotations, decorators, input, output within DSL. We will use it and we will compile this program to the YAML file. And then we will simply upload this YAML file to the kubeflow pipeline dashboard. So here you have an option to upload the pipeline, create new pipeline. Let's say I'll just say test, upload a file, choose file, and I can upload the YAML file that is compiled. But for that, we need a Python program, right? So first, as I told you, I'll just show you with a hello world program. Let's go back to the terminal for it. I'll just take a new tab. We will keep this session so that we can access the kubeflow pipeline dashboard. Just duplicate it. Perfect. We have another session. Let's create a new folder. I will call it as KFP, CD KFP. Whenever you're working with Python, it's not only for your machine learning, it can be for even your DevOps project. Make a habit to create virtual environments in Python. Because when you're dealing with multiple Python programs or different kinds of Python programs, there is a possibility you will run into dependency conflicts. Let's say you're using Python on the same machine for writing a DevOps script and you're using Python for your machine learning. There can be a common dependency with different version, which leads to a conflict. So always it's the best practice to create a virtual environment, which is very simple. Python 3, you should just have Python installed, Python 3 -m venv, which is virtual environment, followed by, I'll just call it as .kfp. Again, whenever you create a virtual environment, make a habit to create it as a hidden folder because you don't want others to view what is in the virtual environment. It's not very important. Also, when you add a .gitignore file, it's very simple to add the hidden files in it. Okay. So Python 3 -m venv, I just created the virtual environment. Now I will source the virtual environment. Source.kfp bin activate. Now what this does, anything that is installed within this virtual environment will only be restricted to that virtual environment. If you deactivate it, like if you just run deactivate, you come out of the virtual environment and the package that you have installed in it will not be on the machine. Okay. So again, I source the virtual environment. The very first thing that you'll install, pip3 install KFP. You can install a specific version of KFP. I would actually recommend that. So go ahead and install KFP 2.9.0. If you're using Python 3.10 and above, you can install directly pip3 install KFP. But if you're using 3.9, 3.8 on your machine, make sure you pin it to this particular dependency version. Okay. So what is KFP? KFP is kubeflow pipeline. So we will be using this SDK or package. We'll use it for creating the pipelines. Okay. Now, how do we write the pipeline? As I told you, we need a Python program. The Python program, I will open it for you. So this is a hello pipeline.py. Within the pipeline, most of these things are shared by the ML engineers itself. Only thing that you would add, as I told you, you will add the DSL decorators. So for every component within your Python program, basically in Kubeflow, different stages of your ML lifecycle are considered as components. As we saw here, there is a stage for data collection or data loading. There is a stage for model training, model evaluation. So each of these things in Kubeflow is considered as a component. So your ML engineer must have written a function for model loading or data loading, must have written a function for data training. Just add a decorator to that function. At the rate is for decorator dsl.component. So when you say dsl.component, Kubeflow will understand, okay, this has to be one of the component of the pipeline so that it can be reused, right? From this point to this point, which is your definition in Python, should be one of the component in Kubeflow pipeline. What happens if it is a component? Basically, for this component, a pod is created and this pod is executed independent of other components so that you can maintain scalability, you can maintain parallelism within your Kubeflow pipelines. So every component has a unique pod. And from wherever you invoke this Python function, so this one is say hello. So you are invoking this from, let's say, a hello function. So there you need to add the decorator for dsl.pipeline. So now this dsl.pipeline is basically the orchestrator. So there are different stages in your ML pipeline, right? Or in your machine learning workflow. All of these components have to be orchestrated, just like how you orchestrate with Jenkins or GitHub Actions. So there you add a decorator called @dsl.pipeline. Very simple. So if we take a real world ML pipeline, you might understand it better. So here we are using a model, and this model will focus on identifying the type of the flower. Okay, so you are writing you are building a model by taking some parameters. It will identify what kind of flower it is. For example, are you dealing with Setosa, or are you dealing with versicolor, or are you dealing with Virginicea? So all that you have to do is you have to provide the sepal length, sepal width, petal length, and petal width. If you provide these four as input to your model, depending upon the input parameters that you have provided, it will identify what kind of species of flower it is. Now for this, you need a data set, obviously. And this data set is going to be your iris data set, which is a publicly available data set. So the ML engineer within the Python program first will write a function for loading of data, where the engineer will load the iris data set. Then there is a function for training of the model. So this is one of your ML stage. This is another stage, which is training of data. And finally, you have an orchestrator, which will orchestrate both loading of data and training of data. That's why for these components or for the stages in ML workflow, you will add @dsl.component and any dependencies that are required in the container image, because it is running as pod. Let's say within your load data, if you are using pandas to read the data from Excel or to read the data from a data set, so you have to add this packages to install pandas and scikit-learn. Similarly, in your second stage, again, you will add @dsl.component packages to install scikit-learn, whatever packages are required. As you keep working on the ML workflows, you will understand the packages, and even you can get this information from your developer, like what packages are required to run this particular stage, or for this Python program to execute, what are all the dependencies, so that you can add the dependency for each of the component. And finally, as I told you, @dsl.pipeline, where these functions are actually getting invoked, load data, train model. So you just provide it with a name and description. You can also skip it. It's not mandatory. Finally, the last stage is to compile. So this Python program has to be compiled to a YAML file, and that YAML file will be published to the Kubernetes cluster, or that YAML file you need to upload to the Kubeflow pipeline. So as an MLOps engineer, what are the things that you'll add? For every function, you should add dsl.component. If not for every function, wherever you feel a stage of machine learning it is dealing with. So for example, loading of data, add dsl.component, training of data, add dsl.component, and where these functions are getting invoked or components are getting invoked, just add @dsl.pipeline. Finally, where you have your main execution, just compile this Python program to a YAML file. So this code will always remain the same. kfp.compiler.compiler.compile, name of the Python function, and what should be your YAML file name. You will realize when I execute these programs. First, let's execute the hello world itself. So I will just copy it. You have these within the GitHub gist. Okay. So here I will create hello_pipeline.py, right? Is the naming correct? Let me just recheck. Yes, hello_pipeline.py. In fact, you can change the name. It doesn't matter. From KFP import DSL, from KFP import compiler. These are the only two things that you are doing. You are using DSL and you are using the compiler to compile the program to a YAML file. Okay, so let's save this. Python 3 hello_pipeline.py. So it's executed. This is just a warning you can ignore. ls, you will find hello world underscore pipeline.yaml. Isn't this amazing? You don't even have to write the YAML file. Now, within this YAML file, if you quickly want to see it, right, this will have the pipeline, right? So this will have whatever are the steps that should be executed within the Kubernetes pods. Remember, we installed CRD. The reason why we installed CRD, because we can define this particular YAML file. Okay. This is a new resource type. Kubernetes does not understand this resource type. That's why Kubeflow pipeline came up with its own custom resource definition. Great. Now, let's go back. Kubeflow pipelines, let's call it as hello. And from the upload, KFP is the folder, hello world pipeline.yaml. Let's create it. As soon as you create it, you will see a DAG. So this is a graph which will tell you what is the status of your execution and what is the flow of your pipeline execution as well. I'll click on create run. You can leave these options to default if you are a beginner. As you progress with Kubeflow pipelines, you can start using service account. You can start using the different parameters here. But when you're a beginner, you just keep the options to default. You can specify the parameter. I'll just call it as Abhishek. So my Python program should return hello Abhishek. So this is not related to machine learning. This is just your very first Kubeflow pipeline, which will say hello Abhishek, hello world, whatever you pass as the parameter. Just to verify your concepts are clear and also your Kubeflow pipelines are working as expected. Okay, start. You can see the status here, pending execution. In the meanwhile, if we get to the Kubernetes cluster, right, kubectl get pods -n Kubeflow, you will see a pod is being initialized, right? And if you change this to the watch mode, you will realize after some time, there will be new pods that are created. Yeah. So you can see right now the DAG driver is being initialized. Once this is done, you will also see the implementation pods, and that implementation pods will actually run your pipeline. You can follow the status here. If I refresh, so you should see a pipeline running status once it gets started. Let's wait. So you can see here, the implementation pod is in init state at this point. So if we go back, we should see perfect. So we can see here the loading or the one that is getting ready. And once it is ready and successful, you should see a write symbol here or an execution symbol here, successful execution. Let's wait. We can keep watching the status here, pod initializing. Once this moves to the completed state, we are all good. Still, pod is being initialized. So for the first time, it took some time. Usually it doesn't take time to at least start the implementation pod. Anyways, it is complete. And if we go back, the DAG shows implementation is successful. You can also click on it to view the input, output, and also logs. So within logs, you can see output is hello Abhishek, right? If you rerun this, let's say I create another run, and this time choose the pipeline. I'll choose the same hello pipeline, and I will change this to hello Veeramala and start. Now you can guess what happens. Go back, you will see a new DAG is created, and again, a new implementation pod will be created. So every time there is a run, you will see a pod in the namespace. It's actually not that difficult to remove the pods if you're worried, but it might keep creating a lot of pods. Don't worry about it. It's actually very easy to remove the stale pods within Argo workflows. I will show you that in the next tutorial as we move to the next steps of Kubeflow. Okay, so the DAG is complete, and if I scroll down, implementation is also complete. Okay, and this time in the logs, we should see hello Veeramala, right? So this is our very first Kubeflow pipeline. Again, this is not at all related to machine learning, this particular pipeline, but this is just to get you introduced to Kubeflow pipeline. Now let's move to the actual one. Okay, so what is our next pipeline? So our next pipeline is a model. So imagine you have a machine learning team, and that team is working on creating a model that takes these 4 things as input: sample length, sample width, petal length, and petal width. By taking these 4 things as input, the model has to guess if the flower is a Setosa species, versicolor, or virginica. This is a very, very popular data set. So you get all 4 of these inputs from a popular data set called IRIS dataset. If any one of you learned machine learning in the past, I'm sure you must know about this IRIS dataset. So what the machine learning engineering team has done, imagine if they're working on this. So they will create a function for or a definition for loading of data. They will create a definition for training of model. And finally, they will invoke them in the order. Now, as a MLOps engineer, I know I'm repeating it, but I just want to make sure you understand it. As a MLOps engineer, to convert this into the ML pipeline workflow or Kubeflow workflow, you need to import KFP, you need to import DSL, and you need to import the compiler as well. And for every stage of your ML flow, you convert that to a component into your Kubeflow. by using @DSL component. So load data is a component, and I want to use Python 3.8 as image for this container, which is running this particular stage. And because I'm using pandas here, right? Within this, I'm reading the data. I'm going to use pandas and scikit-learn. So I'm importing both of these. So packages to install pandas and scikit-learn. And for the next one, which is training of data, I can look at this function. What is it doing? I mean, if you don't understand, let me quickly explain. So it is reading the iris dataset here, and here it is training the model. So a machine learning algorithm is used, which is random forest classifier. And this algorithm is being trained in a way. How is it being trained? So 80%, what does this 0.2 signify here? 80% of the data is used to train the model, and 20% is used to verify the accuracy of the model. This is a very common thing that ML engineers do. Train, test, split. Okay, now that we have it, and in the last stage, compile, afp.compiler, compile this to a file called irispipeline.yaml. Okay, we will copy this as well, and we will see how this works. My Kubeflow is still running in the KFP, vim iris_pipeline.py. You can name it anything. Let's save it, Python 3 iris_pipeline.py. Okay, did it create? Perfect. So it created irispipeline.yaml. Let's go back to our Kubeflow browser, upload the pipeline. Let's call it as flower species identifier. So this is the name of the pipeline that I'm giving. Upload the file, let me choose irispipeline.yaml. Create. The DAG shows there are two things in the pipeline, or there are two components. One is the load data component and one is the train model component. Create the run. Okay, I'll leave the options to default and click on the start button. Again, just like we saw in the previous example, kubectl get pods. So the driver, DAG driver is being created. DAG driver is successfully created. You can see how fast is it this time. Implementation pods are also running. So first one that is running is load data. That's why you see the symbol here. Let's see once it is complete. Right now the pod is being initialized. Once it is complete, we can also see the logs for it. Running. Okay. Refresh this. This should change to complete. Okay. Of course, we can view the logs. So we can just copy this pod and we can see what is the status. We can also see it here. Great. Everything looks good. Let's wait for the implementation to be completed. Great. So this is complete. Now we can see here the entire logs. So the load data is complete. So this is the data. You can see 4 input parameters. As we discussed while going through the code, the 4 input parameters are sepal length, sepal width, petal length, and petal width. So these are the 4 data points in the data set. It's a huge data set and it is completely loaded. Okay, great. Let's see the status of the other one. The other stage, which is train data. Right now, execution is in progress. Logs. Perfect. Train model is also complete. Logs. And what is the accuracy of the model? Accuracy of the model is 0.9. So you have trained the data on these data points. Of course, this code is written by the machine learning engineer. But what you can see here, the accuracy of the model is 0.9. But Abhishek, what did we achieve with this? Right? End of the day, why did we create this pipeline and what did we achieve? So this is a very interesting question. What we are trying to do here, we are trying to reduce the effort of machine learning engineer or the developer. Now, next time, if they add few more things to the data, again, they don't have to manually run the load data. They don't have to train the model and see what is the accuracy of the model. If they are changing the data somewhere in the Python function, let's say instead of this data set, instead of iris data set, let's say they are moving to a different data set. Or maybe they are adding few things to the iris data set. Obviously, load data will change and accuracy of the model will also change, increase or decrease. So they can just come here, they can create a new run because you have already created the pipeline. All that they have to do, they have to create a new run. And with the new run, they can see what is the accuracy of the model. Did the model accuracy go down or did the model accuracy go high? That's it. So this is what you're doing as MLOps engineer. There are only 2 stages at this point. Imagine if there are 10 stages, you have reduced the effort that they need for 10 stages. Every time they can just come here. Once the execution is complete, they can look at the accuracy of the model. Okay, right now accuracy is 0.9. Maybe after next run, accuracy will change to 0.89 or maybe 0.7, 0.6. So they can again fix their code and rerun the pipeline, see if the accuracy has gone high. So this is about Kubeflow pipelines. In this lecture, let's learn end-to-end MLOps implementation for customer churn model. There is a reason for choosing this model in the lecture. Customer churn model is very widely used across different industries today. It is used by telecom industry, retail industry, e-commerce industry, even quick commerce industry these days. So after watching the lecture and after practicing the project, you can go ahead, update this project in your resume, even explain this as your real-time experience in the interviews. You might have a question, but how is this different from the previous lecture? Very simple. Even in the previous lecture, we implemented end-to-end MLOps, but that was using Kubeflow pipelines. In today's lecture, we will learn how to implement end-to-end MLOps using open source stack that we learned. So we will use DVC for data version control. We will use Kserve for model serving and inference. We will use Kubernetes as a target platform. Reason for using Kserve with Kubernetes is simple. Kserve introduced HPA, so it is easy to scale the model in the future for performance as well as the users. We will use GitHub Actions for automating the data scientist activities, something like automating the training process done by the data scientist. Then we will introduce, or we will learn Argo CD to deploy Kserve manifest to Kubernetes. This is the stack that we are going to learn in this lecture. Now, fortunately, this stack is gaining a lot of popularity. If you look at job description for MLOps engineers, a lot of companies are preferring this stack. So this is going to be an added advantage for you. Now, not directly jump into MLOps implementation. Let's first learn real-time use case of this project or real-time use case of customer churn model. Because you need to explain in the interview what is the real-time use case, where you use this model, and how did you improve it using MLOps. So let's take example of telecom industry. Let's take example of Airtel or Verizon. Now these service providers, they have millions of users. Previously, the competition was less, but now users easily switch between the telecom providers. If they are not satisfied with the telecom provider, they move to a different telecom provider. Now this is a worrying factor for these companies. They want to make it easy for their support. So every telecom provider has a support team. Let's say you have some issues with your mobile network or telecom network. You can call them, you can get in touch with the support, and you can resolve the issue. Now, these telecom providers, they want their support team to analyze who are the potential customers or users who are willing to leave the telecom provider. So they have to basically predict. Of course, for support team, it is not easy to predict because they come from a non-technical background. So this requirement is sent to the development team. Now, obviously, even when it comes to development, developers can help with conditions, but they cannot help with the predictions. Developers cannot predict if a customer is not happy with the Verizon service and if the customer is willing to move to a different telecom provider. Support cannot do it. Development team can also not do it. So this is where Verizon team or telecom providers reach out to data scientists and ML engineers. So they ask the data scientists and ML engineers, hey, can you create a model which our support team can use? And using this model, they can predict or they can ask the model if XYZ user is happy with the Verizon service and what is their percentage of churn. So churn is basically iteration or leaving a particular subscription. Now the data scientist and ML team, they would be happy to do it because that's their expertise. They would need data and a model for it. So this is how requirement comes into picture. So this is how a ML project is created. This happens with most of the telecom industries today. Even if you look at e-commerce platform, the competition is very, very high today. If you look at quick commerce, e-commerce, retail industry, everywhere, it's easy for the customers to churn today. They move to competition or they move to alternative. Now you might ask, but Abhishek, what would Verizon do once they have the information? Let's say support understands that XYZ user is ready to churn. What happens then? Very simple. Now support will provide the user with some offer. They might send an SMS or on the website, as soon as the user logs in, user would see an exclusive offer. Now, because of this offer or because of some lucrative offer, the user might decide not to churn. User might decide to stick with the telecom provider. I'm sure you must have seen this. You must have seen that you and your friend use the same telecom provider. You get an exclusive offer, but your friend does not get the offer, right? This happens very commonly with telecom, e-commerce, other platforms as well. You get exclusive offers, but not your friend. This is basically to keep you stick to the platform. And this is all done by the churn models. I hope the use case is clear. Now let's understand how we understood the project requirement. Now let's understand how the project graduates within a company. Initially, the management is the one that decides to implement or that takes the call that we need a churn model. From the management, requirement comes to the data science team. Now it's the responsibility of the data science team to gather the required data and prepare a very good data set. So they collect historical information. What they simply do, they go back, they see the customers who churned in the last 3 years, 5 years, 10 years, whatever data that they have, they prepare a data set using that data. Something like the age of the customer, the tenure of the customer, from last how many years customer is with the platform, monthly payment, yearly payment, and even things like number of support calls, how many times they raise the support ticket. So using such information, a data set is prepared by the data scientist. But Abhishek, what is the advantage of getting information like age, support cases, tenure? Very simple. Let's say now the age of the customer is 19. Basically, Gen Z customer, very flexible. They can easily move from one telecom provider to other telecom provider. They don't have a lot of inhibitions to move from provider to provider. But on the contrary, if you take a 70 years customer, very, very unlikely that this customer would move to a different telecom provider. They are already with the telecom provider. They don't feel like moving to a different one. Right? So age is one of the important data point. Similarly, tenure. If they're already with the same telecom provider for 10 years, they have the trust with the provider. Not that easy for them to move to a different telecom provider. Even if you look at support cases, a very important data point. Let's say in a month, if a user raised 15 support cases, this is a point to worry. Instantly support team, because this would be a churn, support team will send them some offer. Now this month you take 20% discount, or this month you get 50% discount because of the service inconvenience. This is how the data set is prepared by the data scientist in the first step. Now once the data is prepared, I'm sure you can guess it now because you already watched the complete course. Once the data is prepared, the next thing the data scientists do, they start with an algorithm or they start with a model. For example, they choose logistic regression or they choose random forest classifier. And using this algorithm, they train the algorithm with the data. Now, this is a continuous process. As they keep training algorithm with the data, algorithm identifies some pattern in the data that we might not understand. Developers might not create or understand such pattern using the data points, but algorithm understands the pattern and it develops a mathematical function. That is what we call as a model, right? Now, once the model is prepared, okay, with these two steps, data scientist prepared the model. And once the model is ready, ML engineers come into picture and ML engineers, they take this model and they develop API for the model. Typically, ML engineers use Fast API. This is very commonly used these days. Or otherwise, the traditional options like Flask. Once the API is ready, ML engineers also work with performance enhancement or scaling of the models. If they use platforms like Kesa, MLOps engineers use platform like Kesa, this is not very important because Kesa also does this to some extent. Now, why API is required? Now it is easy for the support engineers or even developers within the company. They can prepare HTML file or user interface for the API and support engineers can interact with the API using this HTML. Of course, this is out of the scope for our discussion today, but still just for you to understand how the support engineers access the API. Basically, support engineers don't use a curl request, right? They don't have the terminal. They might not be familiar with it. So what management does, once the model and the API is ready, management asks the development team to prepare user interface or bind the API to the existing user interface of the company. Now the support engineers, they go to a particular page of the website. They provide the information like this, age, tenure, month, year, and support. And once this information is provided, HTML page forwards that request to the API. This way, they get the response back on the user interface. Don't worry, I'll show you all this when we start with the demonstration. But for now, I hope you understood the involvement of data scientists and ML engineers. So this is how the project flows within the company. Now, once ML engineers prepare the API, then comes MLOps engineers, and MLOps engineers start automating the manual activities and automate the deployment process. We saw that in the previous lectures as well. Especially for this lecture, as I told you, we will learn how MLOps engineers introduce data version control. We will learn how MLOps engineers introduce Kesa for automatic scaling. Kubernetes, how do they set up? How do they create namespace? How do they create Kesa controller? GitHub Actions, we will see this as a final step where everything is put in the GitHub Actions. The Kesa manifest, DVC, Kubernetes deployment using Argo CD. Fine. So this is the end-to-end flow of the project. Just like every other lecture in this course, now you must have already been following this MLOps Zero to Hero repository. So this is a repository which has all the sections. Even for CI/CD, you have a section, CI/CD for models. Go to the section. In this section, you will find two folders. Folder 1 for Kubeflow, folder 2 for real-time MLOps project. Just go to this. You will find an MD file, and within this MD file, you will have the link to the GitHub repository that has training scripts, that has MLOps scripts, even it has the CI related scripts. So what you need to do is you need to follow this project or the repository. I have already opened it. So this is the project. This has 2 branches. Please understand this part carefully. So this repository has 2 projects. So 2 branches, branch 1, main branch, branch 2, CI/CD branch. Now in the main branch, you can see everything that is provided by data scientists and ML engineers. So if you join as MLOps engineer in the company, this is what you get. So you get the training scripts, you get the API related scripts, and you also get explanation of the project, whatever I explained till now. And what you do as MLOps engineer, you implement MLOps for this project. That part I have already created in the CI/CD branch. Of course, we will learn that step by step in this lecture, but still, after watching the video, if you want to go ahead and practice the steps, and let's say you're stuck at some point, you can refer the CI/CD branch, right? So main branch is what you get and CI/CD branch is what you implement. Let's go ahead and understand, first of all, what's in the main branch. So there is a README file that explains the project, what exactly the model does, a real-time use case, something that I just explained. And then it also has the steps for the initial setup. This is what is important. A lot of people get confused. They even ask me in the comments, they ask me through different forums, how would a MLOps engineer or DevOps engineer understand how to run the project locally? Very simple. When you join, you get the basic information. That is how to set up the project and how to run the project locally from the developers or ML engineers. If you're into MLOps, you get these steps from the data scientists and ML engineers. So these are the steps to run the project locally. And this is the API that you use to interact with the model. Perfect. Let's go ahead and get familiar with the project. That is, before implementing MLOps, let's understand the files and let's run this project locally. For that, I'll take my Visual Studio Code. Okay, so let's clone this repository, clone from GitHub, provide the complete path of the repository. Okay, so it is real-time MLOps implementation. This is the one. Let me type the entire thing, real-time MLOps project. Okay, so let me choose a folder on my local. I'll go with the sandbox and save the repository here. Open. There you go. So real-time MLOps project. README file, whatever I explained. Apart from that, there is a train.py file. What exactly is this file doing? So this is reading the data from the CSV file. So it is reading the dataset, and on the dataset, it is implementing random forest classifier. So this is the algorithm, and this algorithm is being trained on the data. And you can see here very clearly. So it is using certain amount of data for training and certain amount of data for testing the model. That is the output of the model. And finally, it prints the accuracy of the model. And then it saves the model to our local machine within the models folder. Very, very simple script. In fact, I made this script very simple. I wrote this script, I made it simple because the whole purpose here is not to complicate the model, but to focus more on the MLOps implementation. And there is also API.py file. So API.py file creates API for the model. So here we are using Fast API. Fast API comes with a user interface as well. That is for the documentation and REST API client. That is another reason why I used Fast API. And in Fast API, we create /predict endpoint for the model. Now, if anyone accesses the /predict endpoint, their request goes to the model. That's it. Very simple repository. And I also created generate data.py. This is something you will not find in real time. In real time, data scientists create the dataset. They store the dataset in the CSV file. But because we cannot prepare the dataset, I simulated the dataset using generate data.py. So I'm creating random data and I'm basically storing the data within a CSV file. This is a very simple simulation to avoid using any dataset on the internet. Cool. So let's go ahead and start with running the project locally. I'll take my terminal. Okay, there we go. So this is my terminal. Let's switch to the right folder. So I have to switch to the sandbox folder, and within that, real-time MLOps project. ls, let's see if we have the files that are required. Cool. So we have all the files that we are looking for. Now let's start with setting up the virtual environment. If you watch the previous lectures of this series, you know the importance of virtual environment. So let's create that first. Python 3-m venv.venv. Now let's source the virtual environment. Source.venv bin activate. Okay, so we are within the virtual environment. Now let's install the dependencies. Python 3-m pip install -r requirements.txt. Now good thing is that for most of the projects related to machine learning, these steps are common. Installing the dependencies, creating the virtual environment, almost even running the training script, the steps are more or less the same. So even if ML Internet don't provide you the accurate steps, you can understand that if you learn ML ops for 10 to 15 models. Okay. So we have good amount of dependencies in this project. So it is taking little time. Let's wait. So we can see most of the dependencies are cached. The installation is in progress. 95 packages out of 122. Done. Okay. So we have dependencies also installed. Now we need the training data before we execute the training script. I mean, before I execute Python 3 train.py, I need the training data. So for that reason, I will run Python 3 generate data.py. So this will generate a CSV file for us. I'll walk you through the CSV. Okay. So once the data is created, what does it say? There is an error. So it says unable to save the file. Got it. So I need to create a data directory, because if you look at generate data.py, this is actually storing the output in the data folder, and I don't have data folder. So that's why mkdir data. Now let's rerun the generate data.py. It generated 1000 samples. Okay, let's open the file in the Visual Studio Code. If I go to data, churn data.csv, this is the data set. Customer ID, okay, something that you can ignore. These are the important data fields. Age, I mean, these are the important features. Age, tenure months, monthly charges, total charges, number of support cases, and churn. That is, if the customer will churn or customer will stay back. So you can see here, if churn is 1, most likely customer will churn. Let me go through one entry here so that you understand. 56 is the age of the customer. From last 15 months, the customer is with the telecom provider. Monthly charges is $55 US. Yearly charges is $24.65 US, and support cases are 5 within a month. Now, even without looking this, you can tell the customer is most likely to churn, because there are 5 support cases in a month. The probability of customer leaving the provider is more. Let's see other one. Okay, here the age is almost 70. Okay, and if you look at the tenure, age is 70, tenure is almost 6 years. From last 6 years, the customer is with the service provider. Monthly charge is very less, 30. Yearly charge is 29.33. Number of support cases are 7. Now, the support cases are more, but if you observe carefully, customer is almost 70 years old and customer is with the same provider for last 6 years of time. So that's why in the data set, the entry is 0. This way, there are 1000 samples in the data set. Perfect. Now let's run train.py. Python 3 train.py. Now this will create a model for us. Obviously for the first time, because algorithm should identify the patterns, it has to develop a mathematical function. It will take time. But when you do the same thing for second time, third time, it will take little less time when compared. Okay, let's see, there is some error. No such file or directory. Let me do ls. Okay, again the same thing. Let me create a folder called models and rerun the Python 3 train.py. There you go. So now to the models folder, churn model.pkl is created. Let's see ls models. Okay, so this is the model pkl file. We cannot directly send a request to the model. So what we'll do, we will create API for the model. Of course, we are not creating it. The ML engineer already created API.py. Let's run the API.py. Python 3 API.py. There you go. So it says now the model is running on 0.0.0.0 8000. Now, very simple thing. Either you can directly access this using the curl request. So I'll take another tab here and I will send the curl request according to the documentation. So I'll just scroll down, API usage, copy the curl request and paste it here. So you can see churn probability is 0.53, but churn is 1. That is, most likely this customer will leave if you don't care about the customer. Why? Age is 45, tenure is only 2 years. Monthly charges are high, 80. Yearly charges, along with maybe other subscriptions, is $2,000 US. And just in 1 month, they created 3 support requests. Age is less, tenure is also less, support cases are more. So most likely, customer will churn. We can also do the same thing through the user interface. So if you just access localhost 8000/docs, the one that is provided by Fast API, let me show you here. So on my browser, I search for localhost 8000/docs, and I'm able to access this user interface provided by Fast API. So here I'll search for /predict API and click on try it out. So I can just provide the parameters. Let me say age as 70, tenure of months. Let me just provide tenure as 60 months, that is 5 years. Monthly charges, let's say 30. Total charges, let's say 1000, and support cases as 1. Okay, let's execute this and see. Internally, it made the curl request and we got the response as churn 0. That is, this customer churning probability is less than 0.3. So that's why it says the customer will stick to the same service provider. Even if you look at the parameters, you can guess. Support cases are not many, age is also high. So this way, you can access the model from the browser as well. Either you access through the curl request or access through the API. I mean from the browser. Okay, now that we understood the model, now that we know how to run the model as well, let's start with MLOps implementation. One more time, I want to make it clear here. At any point of time, if you are not able to follow, I mean, while you are practicing, if you don't recollect the topics that I explained in this lecture, you can go back and switch to the CI/CD branch. In the CI/CD branch, I already placed the manifest and scripts along with the steps. If you look at the README file of CI/CD branch, along with the initial steps, you will also find the DVC steps. You will find the steps to push model to the S3 bucket. You will find steps for Kubernetes cluster creation, case of related steps. Even you will find steps related to GitHub Actions. Everything is in this CI/CD branch. So you don't have to worry. Let's start with DVC. So we all know what is DVC. We learned that in the previous sections. Just to recap, DVC is data version control that is used for storing different versions of the CSV file or your data set. So we learned that in the previous sections as well. Just for source code, we use Git. And when it comes to CSV files or dataset, because they are huge, we cannot store them in Git. So we will use remote storages like S3. And the metadata information or the checksum information of the CSV files is stored in the Git repository so that all the team members can sync with the same version of the CSV file. So they can look at the CSV file version in the Git repository and they can download the relevant version from S3 bucket. We learned this in DVC section. If you have any questions, just quickly go back and revise the DVC concept. So for now, I'll proceed with the DVC part. First thing that we do is run python 3 -m pip install DVC. So you should do that in the same folder. Then do python 3 -m pip install DVC S3. Why are we using DVC S3 package? Because we want to use S3 bucket as a remote storage. Now commands are very similar to Git. First command that we execute is DVC init. This will create a .dvc folder just like .git. So you can see here, this .dvc will have the configuration. Now once we have .dvc, next thing that we do is add a remote storage. Just like git remote add, we will run DVC remote add. But for that, we need S3 bucket, which we will use as remote storage. In my AWS account, I will create an S3 bucket. Of course, I can do this from the CLI as well. But just to show you, bucket name, I'll choose the name of the bucket as churn model demo Abhi bucket. Make sure name of your bucket is unique. Create bucket. Okay. So we have the bucket created. I'll just copy the name of the bucket and add it as remote. How do we do it? DVC remote add -d. I'll call it as S3 remote followed by S3:/ name of the bucket. Don't worry. All these commands are in our GitHub repository. Okay. So we have S3 as the remote now. Now let's add the CSV file to the remote storage. Okay. This is good practice. Even if you don't store the CSV file, it's fine. But when you are working in a large team, there is a chance that you might be training model with a version of CSV file and your colleague might be training the model with different version of the CSV file. So that creates discrepancies in the team. Anyways, so let's add DVC add data/churn.csv. Okay, what does it say? It added to the .dvc. Now let's run DVC push. There you go. So this will push the CSV file to the S3 bucket. Now if you go to S3 and refresh the objects, you can see the files folder MD5 57 followed by the checksum, and here you have the file to download. So here we have the file. We don't have any versions because that's the first version. But if you click on the download button, you can see the CSV. Perfect. Now we are not done yet because whenever you deal with DVC, you should not stop here. You should push. So now if you look at the data folder, along with churn.csv, you will also find churn-data.csv.dvc. What's in this file? Okay, so this file will have the S3 bucket related information. So you can see 57 followed by the checksum. This is the same folder number. If you just copy it here and paste it, you will find the same number. Perfect. Okay, this way, every member in the team will use the same version of the CSV file. Tomorrow, if you update the CSV file, you should add the CSV file again to DVC and you should again push it to the storage. Perfect. So we will run DVC push. My bad. So this time we will run git push because we already did DVC push. Let's do git status. Okay. So these are the changed files. let's run git add to add the DVC related files. But one thing, usually you should not push .dvc. So what we will do here, we will create a git ignore file .git ignore, and within the .git ignore, let's add .dvc. If you are comfortable adding your .dvc as well, then you can just ignore and just run git add. Okay, then run git commit. What are we committing exactly? Sure, DVC related files. Okay, and once you're done with this, just run git push. I'm not doing it at this point because I want to keep my main branch clean so that whenever you try to practice the same things from the repository, you will not have any DVC related things. That's the only reason. Otherwise, at this point, you can just run git push as well. Perfect. Okay, we are done with DVC part. We stored the CSV file, the first responsibility of MLOps engineers. What's next? The next thing is to store the model as well. You need a model registry. In our case, we will store the model in the same S3 bucket. When it comes to continuous integration, I'll show you how to automate these steps using GitHub Actions. But first, always do the manual things, right? So at this point, we will manually push the model. This one here, churn model.pkl. Let's push this to the S3 bucket. How do you do that? So simply, you can go to the S3 bucket, and within the S3 bucket, what I'll do here, I will create a folder. So I'll create a new folder for model. So within the model folder, in fact, you can use two different S3 buckets as well, but there is no point for our demo project to create two different S3 buckets. That's why in the files folder, I'm storing the CSV file, and in the model folder, I will store the model.pkl file. Okay, let's head to the model folder, click on upload, and from the local, I will upload the model, churn model.pkl. Perfect. Okay, so I added the model file as well. Click on upload. This will take no time. The model is now added to the bucket. Perfect. So we push the model as well. So we are using S3 as model registry and also as remote storage for the DVC. Now let's create the Kubernetes cluster. So if you see, we are following the step-by-step order. First, we are done with the DVC. Now we will head to Kubernetes and Kser. So for that, I will first create a kind Kubernetes cluster. First, let me see if I have any clusters. Okay, I don't have any kind cluster. I'll create one, kind create cluster -- name. I'll call the name of this cluster as churn model cluster. Okay, so I have a kind cluster now. It's up to you. You can create Minikube, you can create EKS, AKS, but kind is very simple. That's why I usually prefer kind. Now we should install Kserve in this cluster. How do we do that? The best thing that you do, if you want to install Kserve, don't go to the official documentation. Unfortunately, there are some issues. Instead, go to our MLOps repository, the one that we are using for this Udemy course, and go to the Kserve section. Here, go to end-to-end demo and start installing Kserve. First, we will apply the cert manager. Okay. So now this should create the cert manager for us. All the CRDs are created. Good. Now let's install Kserve related CRDs. Okay. So the Kserve namespace is created. It's pulling the version from Helm, and it created the Kserve controller as well. We can check kubectl get pods -n Kserve. Okay. It says no resources yet. So let's wait for the CRDs. We don't have to look at the Kserve namespace. So we can just check kubectl get CRDs. Okay, we can see Kserve related CRDs installed. So we are good. Now let's install the Kserve controller. After this, we should look at the Kserve namespace. Okay. So you can see there is already wait condition. That means the Helm command will wait for the Kserve controller. Only when the Kserve controller is installed in the namespace, you will see the execution as complete. So let's wait for it, for the controller to be installed. Let's verify the pods. kubectl get pods -n Kserve. Perfect. So we have the Kserve controller also ready. Now we can go back to the documentation for our repository, the project that we are currently working on, right? So what is the next step that we have to do? We have Kserve installed. We have Kubernetes cluster is also ready. Now we have to just deploy the model to Kubernetes. For that, we will need the inference file, right? But let's try to understand this point here. You cannot directly deploy the model. So if you try to take the model from S3 bucket, let's say I create inference file, okay, inference.yaml file. And in the inference.yaml file, if I provide S3 bucket as a location, what happens? Inference file or the Kserve controller will fail to download the resource from S3. Reason is simple. By default, we will not make S3 bucket public. Even in your organization, you will not make the S3 bucket public. So what you have, the model in the S3 bucket cannot be downloaded. That's why what we will do in this case, we will create a service account in Kubernetes. Okay, understand this carefully. We will create a service account in Kubernetes, and for this service account, we will grant access to the S3 bucket using AWS credentials. So we will create AWS credentials, and then within the service account, we will grant that S3 related permissions. Basically, AWS related permissions. How will you do that? In the service account, you will add a secret, and that secret will have AWS credentials. Cool. Once you have the service account, in the inference YAML file, we have to provide the name of the service account. And rest is taken care by Kser. Once again, I'll try to explain this. In the usual case, you can directly create inference file. That's what we did in the Kser section as well, because we stored that in a public registry. In this case, we are storing in S3 bucket, and S3 bucket has the model which is not public in nature. In your organization, you will not make the S3 bucket public. So what we will do in Kser, when we create the inference file, along with the inference file, we will create a service account, right? This service account will be used by the deployment that is created by Kser, and this deployment will be able to pull the model from the S3 bucket, and it will be able to run the model within a pod. So that's what we are going to do. Perfect. So I'll first create a namespace for this. kubectl create namespace. Let me call the namespace as ML. Okay. Now within this namespace, I will start with creating the service account. As I told you, even these manifests are within our GitHub repository. So the service account file, let me call this as svc account.yaml. Okay. I'll paste the manifest here, and then I'll explain you. Namespace, we don't have to do. I already created a namespace. So let's remove this part. So I'm creating a secret in this manifest. Secret, S3 secret. And if you observe carefully, here in the string data, I'm providing AWS access key ID and AWS secret access key. I have both of them with me. So I'll just paste it here. If you don't have your AWS access key ID and secret access key, please go ahead and create that. Copy it, paste it here. In the same way, even for secret access key, I'll just paste it. Cool. Then we are creating a service account that is using, you can see the name of the secret, S3 secret, S3 secret. So this is the service account that we are creating, and this service account is using the secret that is provided. I should just change the namespace to ML because I created a namespace called ML. Okay. Let's save this file and let's create it. kubectl apply-f service account.yaml. There you go. Now if I do kubectl get sa-ml, we should see that. Finally, let's proceed with inference.yaml. So I'll create a file called inference.yaml, and within this file, I will paste the inference related content. So this is the API version that is always constant. The kind inference service namespace has to be ML namespace. This is the only thing that you need to change. Service account name, SA, S3 access, and storage. Where do we have the model? This will change. Go back to the S3 bucket. So this is the location of the model. Just copy the location here. Copy and paste. Now this should have our model running in Kubernetes cluster. This is the beauty of Kser. It takes care of deployment. It takes care of service. It takes care of horizontal pod autoscaler as well. In few minutes, we should have our model running in the cluster. kubectl get pods -n ml. Let's wait. Okay, so till now we don't have it. It's created in the right file. kubectl apply-f inference.yaml. My bad, I forgot to execute it. Okay, now let's wait for the pods -w. It's initializing. This should move to running state. There you go. So 1 out of one is in the running state. Cool. So now what we'll do, we will try to inference the model. Because I'm using kind cluster, I cannot directly access it using service. So I'll port forward the service. kubectl get svc -n ml. Okay. So I'll run kubectl port forward followed by svc / name of the service. Perfect. What is the port of the service? 80. I'll use 7000 on my local machine. Or let's use a random port 6009 :80. That's the name of the service. -n ml. This should do. In some cases, you might have to append -- address as well. Okay. So just to be safe, let's do that as well. Hyphen address 0.0.0.0. Okay. Now on port 6009 of my local machine, I have the model running. Now we'll use a curl command to verify. I'll show you where do you get the curl command. Just go to the Git repository, CI/CD branch, scroll down, and here after the ksub section, you can find the curl command. So this is the curl command that you need to execute. Copy and paste it in the other tab. Only one change in my case. I'm using port 6009. So 6009. Let's verify. There you go. So prediction is 1. We can also change something and see. I'll change the support cases to 0. Okay, so still we get the output. That means the churn model is working absolutely fine. We learned how to deploy that to the Kubernetes cluster. So what did we learn till now? We learned how to implement TVC. We learned how to implement KServe. We learned how to implement Kubernetes. I mean, how to deploy the KServe manifest to Kubernetes as well. Now let's automate this using GitHub Actions. So I'll go back to my Visual Studio Code and start writing the workflow. Very simple. Let's go step by step. Even in the workflow file, I'll explain you step by step that we need to execute in the workflow. First thing, create a folder. So I'll call this folder as .github. And within this folder, create another folder called workflows. Now within this, create a file. This is going to be our actions file or the workflow file. Usually people name it as ci.yaml. Let's name it something relevant. MLOps pipeline.yaml. Name does not matter. You can provide any name here. Okay. Now within this file, let's start defining our workflow. The first thing that you do, provide the name of the workflow. I'll call this as MLOps pipeline. Then you need to define the on action on which the workflow should be triggered. That is, do you want to trigger the workflow on a pull request or do you want to trigger the workflow on a push action? In my case, I will run the workflow on the push. Branches, let's use the CI/CD branch so that I'll keep the main branch clean. And even when you copy my main branch or when you look at my main branch, it does not have the GitHub Actions. You can go ahead and create everything from scratch. Okay, push action is also defined. Now let's declare any environment variables that we need. So throughout the workflow, if you are going to use any variables, this is the section where you declare. I'll declare AWS region and S3 bucket. Let's use a different S3 bucket this time. So previously we used the S3 bucket for manual action, everything that we pushed manually. To keep the CI/CD bucket different, I'll call this as churn model bucket CI/CD demo or CI/CD abi. Okay. So these are two environment variables. We would also need AWS credentials, but that thing I will use in secrets because I don't want anyone to look at my AWS credentials. So I cannot use it in environment variables. Perfect. Now let's start declaring the jobs. In fact, I'll only use one job this time, train and deploy. If you want, you can break this into two jobs, one job for training and one job for deployment. Okay. So here, let's write on which virtual machine. So GitHub Actions, whenever you execute it, it has to run on a virtual machine. This is the place where you define the virtual machine. So this training job should run on Ubuntu latest. If you want to go with a different virtual machine, you can do that as well. Also, declare the permissions. You know what permissions should GitHub Actions have for this job? Contents write as well. So read is by default. I would need contents write as well. The reason is simple. End of the day, once a new model is created, I want GitHub Actions to update the version of the model in my inference.yaml file. If you remember, when we created the inference.yaml, I provided the location of the S3 bucket. Now I don't want to use the same model version every time. So that's why whenever GitHub Action creates a new version of the model, I want it to be updated in the inference.yaml file. That's why I'm granting the permissions here. Permissions, content, write. So now the GitHub Actions can edit any of these files, including the inference.yaml file. Or it can create a new file as well. Perfect. So let's start defining the steps in our job. The first step is to check out the code. Okay. So I will write this step. Steps. Name is checkout. I'll use the action for the checkout with the token secrets.github token. You don't have to define the GitHub token here. It will use the default token. Okay. Then within the steps, let's declare the next step. What is the next step? When you did manually, what did you do after cloning the Git repository? After cloning the Git repository, you install the dependencies. You will do the same thing now as well. Okay. In the steps, make sure the indentation is right. In the steps, I'll paste the next one, install dependencies. I'll create a white space here so that it's easy for you. Pip install -r requirements.txt. Okay, I forgot to set up Python before installing the dependencies. I need Python installed on the virtual machine. Let me do that as well. So before this step, I will install Python. Setup Python, actions. This is the Python GitHub actions. And I'm using the version 3.11. Now you might ask, Abhishek, how do we note these actions? If you go to the GitHub actions documentation, you will find all the actions along with the documentation for each action. Okay, we installed the dependencies as well. What's the next step? If you remember, the next step that we did was to generate the dataset. So Python generate dataset.py. And then we train the model. So the next step is to train the model. Train model, Python train.py. Good. So this will train our model as well. Then we need to push the model to the S3 bucket. But before that, I need AWS credentials. So I will configure the AWS credentials using this action here. So AWS actions, configure AWS credentials, where I am providing my AWS access key ID, AWS secret access key, and also AWS region. Now this thing we should set up in the repository. Okay. So right now you can see here secrets.aws access key ID. When you prefix it with secrets, that means GitHub actions will look at the secret in the Git repository. Once we commit this file, I'll show you how you can set up the secret. Okay, perfect. We set up the secret as well. Now let's push the model to the S3 bucket. So AWS S3 copy models churn model.pkl. I will push it to the churn model demo abhi bucket to the models folder. Cool. I have to create this bucket. Right now, this bucket does not exist. Right? So we will even create this particular S3 bucket. And then once you push this to the S3 bucket, we just need to update the inference file. So this is how you update the inference file within the same GitHub repository. Name, update inference.yaml with S3 model path. So what I'm doing here in this Git repository, let me show you. So here I have the KX folder. In the KX folder, I have inference.yaml. Here I am updating this particular string with the latest one. Okay. So this string will be replaced using SCD command. And what it will be replaced with? It will be replaced with the new churn model.pkl from the S3 bucket, new version. Cool. Commit updated inference.yaml. This is what we are doing. So these are the steps that we will execute in the GitHub actions. Now I have the exact same file in the CI/CD branch, so I'll not commit it. If you look at CI/CD branch.github workflows, you will find MLOps pipeline.yaml. The exact same thing. Okay. Before executing it and verifying it, what we need to do? We need to first create S3 bucket with the name. Okay. So I'll go to the bucket section, general purpose buckets, and create a new bucket. Name of the bucket. Let's copy it from here. Bucket name, scroll down, create bucket. Along with that, I should also add my AWS credentials to GitHub repository. How do I do that? Just go to this repo, real-time MLOps project, right? Within this repo, I have to head to the settings, and within the settings, in the CI/CD space, secrets and variables, go here, go to the actions section and add the secrets, repository secrets and moment secrets. Okay, so I'll add repository secrets. This repository has no secrets at this point, but I'll create one. What is the name of the secret? So let's see what we provided in the CI/CD file. AWS access key ID, copy, paste it here. The name of the secret, the value of the secret, I have it stored on my local machine. I'll just paste it. Okay, add secret. Similarly, we will add another secret, repository secret. This time, what's the name of the secret? So we can check it from our VS Code. AWS secret access key. Okay, and paste the value as well. Don't worry, I'll delete this as soon as the lecture is complete. Okay, also you try to do that because the secrets are always sensitive. Fine. So I added the repository secrets, AWS access key ID, AWS secret access key. Cool. So now I'll just go back to the CI/CD pipeline, this one, CI/CD branch, and let's execute the action. How can you execute the action? Very simple. To execute the workflow, just push a commit to the GitHub repository. Okay, so I'll push a new commit to the repo and verify if this will invoke the model and this will create a new version, and also if this will push the new version to the S3 bucket. Let me just change the echo statement here. Model push to S3 successfully to model change to S3 is success. I'm just making a very, very simple change and I will do a commit. So basically I'm performing a push action on the CI/CD branch. Now let's see. So we will go back to the repository. We will switch to the CI/CD branch. So you can see the actions is running. Let's check the status of the action. Okay. So it's installing the dependencies. Very good. Yeah, so installing dependencies, it's a big one. It has to download a lot of packages and it has to install them. It's expected that it's going to take time here. Okay, so still it's installing the dependencies. Once it is done, it should proceed with generating the dataset. Okay, it generated the dataset. Oh, it moved very quickly. Yeah, that's the advantage of CI. So, all these actions execute in the steps that we defined. So generating the dataset is complete. Training the model is complete. Even it pushed the model to the S3 bucket. Oh, nice. Let's see. So this is the bucket that we created. It pushed to the bucket. Ideally, this bucket was empty because I just created the bucket only for CI/CD. Now let's go to it. Okay, churn model bucket CI/CD Abhi. This is the one that we created later. So within this, okay, it says there is nothing in it. Let's refresh and see. There you go. So it created models folder, and within the models folder, we have chainmodel.pkl. It just created it. So the folder was empty, and entire the bucket was also empty, and it pushed the chainmodel.pkl. Now here is the interesting thing. Let's see if it updated inference.yaml file or not. That's the most important thing. It should update inference.yaml file with the version of model PKL that it pushed. Okay, so we will switch to CI/CD branch. Let's see. In the K8 folder, I have inference.yaml. There you go. Chain model bucket CI/CD Abhi model chainmodel.pkl. We can slightly modify the SCD condition so that it pushes the new version every time. That's a very simple thing. I'll update that in the CI/CD file. But for now, I hope it is clear how GitHub action works. Cool. So now it pushed the S3 bucket file. All that we have to do is using Argo CD, we have to deploy this inference.yaml. Best part about Argo CD, you can deploy it in the same cluster or you can deploy it to a different cluster as well. You only have to configure it once. Every time GitHub actions make change to this storage S3 string, Argo CD identifies the change and it deploys the new version of the model to the Kubernetes cluster along with inference. How can we do it? Let's also do it on the cluster. Okay. So here, let me recheck if I'm connected to the cluster. Kind get clusters. Okay. Let's go back and get to the Argo CD documentation, Argo CD docs. Perfect. Here, just head to getting started. Okay. So you have install Argo CD. Copy it and run it here. So this will install Argo CD along with all the manifests for us. However, we are using kind cluster. So still we have to expose the Argo CD service using the kubectl port forward, and only then we can access the Argo CD user interface. Perfect. kubectl get svc -n Argo CD. Which service we need to access? We need to access the Argo CD server service. So let's run kubectl port forward. Okay, so the forwarding is enabled. Now on port 7003, we should access Argo CD. Let's try that. So I'll take my browser and try to see if I can access Argo CD on port 7003. Localhost 7003. Okay, advanced, accept the risk and continue. There you go. So we have the Argo CD user interface. Now we just need user ID and password. So we can get that from Argo CD secrets. kubectl get secrets -n Argo CD. So you can see Argo CD initial admin secret. So this will have the secret value. So we can get that. We can just do kubectl edit. I'm just trying to read the secret. Edit secrets -n Argo CD. Okay, so this is the value. Copy. This is base64 encoded. So let's do echo the complete string followed by base64 - decode. Okay, so we got the value. Let's copy it. Go back. Username is admin. Paste the password. There you go. So now I logged into my Argo CD instance on the Kubernetes cluster. Let's create a new application within Argo CD. App name, kserve, project name, default, automatic sync so that every time when the file is changed, it identifies. Then let's provide the GitHub repository URL. So this is going to be the GitHub repository URL. Let's copy, paste it in Argo. Okay, so we pasted it in Argo as well. Revision path. So here we can select the branch. So what is the name of the branch? The name of the branch has to be CI/CD. Perfect. Path. Which path Argo CD should refer? So it should refer the K8 folder. So within the K8 folder, it has inference.yaml. So let's say, we'll ask it to reference K8 folder. Perfect. K8 is a folder. It will look for that path. Destination cluster, the same cluster in which it is. And namespace. Let's provide the namespace, something different this time, so that you understand how Argo CD performs the deployment. In the ML namespace, we already have the manifest. So this time, let's choose, let's call this as churn demo. Okay, this is the namespace. Directory is all good, includes, excludes. We don't need anything. So let's create the application manifest. If your Argo CD application manifest is correct, you don't have to worry. Everything will be taken care by Argo CD itself. So now let's see kubectl get pods -n churn model. Okay. So it says crash loop back off. Any guesses? What must have happened? Now, if you observe carefully, in our GitHub repository, in the service account.yaml, when we did the manual deployment, we granted the access key ID, secret access key ID in the service account.yaml. But because this is in the GitHub repository, we cannot provide the secret values in the repo. So that's why the container is in the crash loop back off. You can see if I do kubectl logs followed by name of the pod. So this is the name of the pod. I do all containers and in the namespace churn model. So you will see the crash loop back off because it does not have the enough permissions. Cannot locate the credentials. I did not provide the credentials and it was intentional. So we will edit the secret here. Okay. In Argo CD, you need secret management. Whenever you are dealing with secret, either you edit the secret locally or you go with secret management solutions, something like seal secrets operator or any other inbuilt CSI secret store operator. Okay. In my case, I'll go with editing the secret because this is a demo. kubectl edit secrets followed by name of the secret. Let's get the secret name. kubectl get secret -n churn model. Okay. kubectl edit secret S3 secret -n churn model. Okay. We are almost there. I'll paste it from my saved things. Okay. This is the secret value and this is the access key. Perfect. Saved. Now this should actually work. So if you go back to Argo CD, you can press the resync option or you can delete the deployment and try again. Let's see this time. kubectl get pods -n churn model. Now this time it should work. Yeah. So churn predictor, this is up and running. In the same way, we can just expose this pod using kubectl port forward and verify it. Let's do it. kubectl port forward. So let's use a different service this port this time. kubectl port forward pod followed by name of the pod. So we need to know the exact So let's try again. This time after making the change. Now let's see. kubectl get pods -n churn model. Perfect. So the pod is in the running state. Let's get the service as well. kubectl get svc -n churn model. Now we will expose the service using port forward the same way. kubectl port forward svc followed by name of the service. We'll use a different port this time. Let's go with unique port 8114:80. Address. Some of you might be running cluster on a virtual machine. That's why I keep using this address. Otherwise, it's not required. -n, we'll use our namespace. Cool. Let's run the curl command and verify. So I'll take another tab. I'll go back to my documentation. One thing that you need to remember, Kserve runs the model on a complete different endpoint. So do not run the same thing that you ran while verifying the model locally. Go to the CI/CD branch and scroll down. You will find the API command. So this was the API usage regularly. In the Kserve section, you will find a different endpoint. Okay. So this one here is the Kserve related endpoint. Let's copy it and paste it. So local and this one is slightly different. Let's paste it and enter. Okay. It's showing an error because I'm using the wrong port. Let me change the port. So the port that we used, I guess, is 8114. I'll quickly cross verify as well. 8114. There you go. So we have the prediction from the model. So this way you can use GitHub Actions and Argo CD combination to implement end-to-end MLOps, right? So what we saw today, we use GitHub Actions to run all the steps, automate the steps related to training and deployment, basically updating inference. And from there, Argo CD took over and Argo CD deployed the inference file to the Kubernetes cluster. Setting up Argo CD is definitely a one-time manual activity. If you're thinking about creating this Argo CD instance and creating application, yes, you need to do it. You need to do it only once. From next time, whenever there is a change to the inference file, Argo CD will identify and deploy to the cluster. CI/CD part looks easy when I explain, but I would highly recommend you to go back and try to implement it at your end. I'll try to update the documentation in the GitHub repository to make it as simple as it for you. Perfect. So this is about end-to-end MLOps implementation using DBC, Kserve, Kubernetes, GitHub Actions, and Argo CD. All right. I hope you learned a lot through this course. Now let's focus on the key takeaways. So it's important to recollect what we learned in this course and also to put the same things in the resume. In this lecture, I'll help you recollect the things that we learned. So we started with understanding what is MLOps. Then we learned what is the scope of MLOps engineers through a beginner-friendly project. Then we learned about data version control. We explored how to implement DVC in real time. In the next section, we learned about experiment tracking and how to use MLflow for experiment tracking. The best part is that we learned production-grade MLflow setup, and we also learned how to visualize the differences between two experiments. Then we focus more on deployment and serving because it's a critical activity for MLOps engineers. We learned model deployment and serving in 4 different ways. One is on the AWS virtual machines using web server gateway interface. Then we learned using Kubernetes clusters. We learned how to set up the cluster, how to containerize the model, and how to deploy the model onto the KX cluster. Then we learned about Kserve, which is a very popular MLOps platform. We learned how to use Kserve inference service to deploy the model from a model registry. Finally, we also learned about a managed platform, that is AWS SageMaker. We explored how to set up SageMaker, what are domains, what are user profiles, how to implement strict RBAC with SageMaker. On top of that, we also learned how to use Jupyter Labs, how to create model, and how to deploy the model as well as endpoints using SageMaker AI. Then we focused on Kubeflow pipelines for orchestration of the pipelines. In the next few days, you will also see the complete CI/CD using GitHub Actions, DVC, MLflow, and Kserve, including Argo CD live. If you're watching this course during the launch, you might not see this lecture because this will be live in the next few days. So these are the key takeaways of this entire course. In the next lecture, I'll help you prepare the resume for this course. Finally, you want to transition to MLOps roles, I'm sure. So it is important to put the right points in the resume, and you should be able to explain those points in the interview. One final thing before I sign off, make sure you learn the things and implement the things practically. A lot of people approach me, Abhishek, I don't remember the things that I learned. I keep learning every day. The simple reason is because you don't practice the things. If you go through this Udemy course, you might quickly go through the lectures, but trust me, when you start practically implementing the lectures, you will learn a lot of things, even the things that I might not have covered, because you will run into issues and you will spend troubleshooting the issues. So that's all for this lecture. I hope once again, you enjoyed the course thoroughly. Okay, so now you learned MLOps from this course. I'm sure you have a question, how to transition to MLOps profile or how to show your experience as MLOps engineer in the resume. Don't worry, I'll explain you that part as well in this lecture. So basically, let's say you come from DevOps or cloud background. I assume a lot of you come from DevOps or cloud background because it's easy to transition to MLOps from this background. Or even let's say you come from a different background, you can just follow the same things. In your resume, the one that you already have, so you have your professional experience. So let's say you have your experience as DevOps engineer, just add a new section. Okay. So simply add a new section, and within this new section, write down the points that you learned. So change your profile heading to MLOps engineer and write down few important points that we learned from this lecture, from this series. Let me help you with few points. And don't worry, in the notes of this lecture, you will also find, right? In this section, you will also find 20 interesting points that we learned in this series. So you can pick up few points from those 20 points and you can add them to your resume. Let me explain how to add them. For example, we learned how to design end-to-end MLOps workflow. So you can just add a point, designed and implemented end-to-end MLOps workflow. Just say covering model training, versioning, deployment, serving, and lifecycle management. So this is one point that you can add. Then we learned how to productionize the models, right? So we saw how data scientists create a model. Then we learned how to make this model production ready by implementing the infrastructure and MLOps practices. So you can also add a point related to that. We learned how to implement web server gateway interface. We learned how to implement gUnicorn, how to create Flask API. So you can also add a point related to that. Implemented custom model serving using Flask plus gUnicorn WSGI to understand low-level model serving before adopting the managed platforms. That is, even before going with Kserve or going with SageMaker, you can say in the lower level moments, you have implemented model serving using Flask as well as gUnicorn. See, this is how you write the points. It's not that, you just say I know MLOps or implemented MLOps using Flask, but write the point in the resume in a way both the recruiter as well as the interviewer gets interested in your profile. And if you observe carefully, I'm focusing a lot on the keywords, end-to-end MLOps workflow, model serving using Flask and GUnicorn. So if you highlight these points, it's easy for the recruiter to prioritize your profile. We also learned containerizing the machine learning workloads using Docker. So you can highlight that point as well. Containerized machine learning workloads using Docker, ensuring reproducible builds and immutable model artifacts. Again, keywords are very important here. I have used the keyword model artifact, I have used the keyword Docker, I have used the keyword containerization in the same line. This is just like SEO optimization. When someone creates a website, they make sure their website is SEO optimized. In the same way, when you create a resume, make sure your resume is also optimized. We also learned how to deploy the models to Kubernetes. So why to miss the opportunity? Put the point in the resume because Kubernetes is a highly rated keyword these days. So you can say deployed ML models on Kubernetes clusters and implemented Ingress for scalability. Along with that, we also learned, let me scroll down. I'll add a few more points. So you can pick up points as per your comfort. Once again, I'll share the points in the Udemy course section as well. Okay. So we learned K-serve-based implementation. I covered the Kubernetes part here, but we also learned how to implement advanced Kubernetes deployment using K-serve. So you can highlight implemented K-serve-based model serving, leveraging standard inference APIs and cloud-native deployment patterns. K-serve is very important. I told you during the lectures as well, because K-serve is gaining a lot of popularity. Even platforms like SageMaker, they are trying to implement integration with K-serve. So add K-serve to your resume. On top of that, you can also talk about how you have implemented K-serve-based managing for scalability as well. So you can say compared and evaluated Flask-based serving versus K-serve managed serving. So you can say here, you don't have to create an API, you don't have to containerize it. When it comes to K-serve, you can just provide the .pkl file in the model registry location. That's the beauty of K-serve, right? It makes the deployment and serving super simple. So you can elevate that point in your resume that you understand K-serve better. You can also say you have implemented model registry using S3. We did that both during the MLflow and also during SageMaker. So you can say integrated external model artifact storage like S3 buckets for model deployment in Kubernetes. We did this part during the K-serve lecture. In Kubernetes, we used S3 buckets as model registry. You can also talk about SageMaker. Very, very important point I'll add here. Understood and applied SageMaker domain, user profiles, IAM execution rules, ABAC, along with access control and security patterns. Even I highlighted this during the lecture that a lot of people don't understand how to implement SageMaker in production. So it's a value add to your resume. We learned that in detail in the section. So make sure you highlight that in your resume. In case interviewers ask you, what exactly did you do with SageMaker domain and user profiles? You can highlight the ABAC concept that you learned. Similarly, you can also say, I'm good with implementing end-to-end MLOps for IAM point of view. So you can explain in your organization, there are data scientists, ML engineers, MLOps engineers. So within SageMaker, I have separated the permissions using IAM-based roles. So you have implemented proper RBAC with SageMaker. You can also talk about deployments to SageMaker. How did you deploy? But on top of that, you can add an interesting point where you have applied CI for your MLOps. Applied MLOps automation principles using CI concepts for model training, artifact generation, and deployment readiness. We saw this part in the very first section where we try to understand what is the role of MLOps. And I have also implemented end-to-end CI/CD for MLOps. At this point of time, if you're watching this lecture during the course launch, it is pending live. But if you're watching 10 days after the course launch, that is roughly around 25th of December, you should already find end-to-end CI/CD pipeline implementation for MLOps. You can also talk about Kubeflow, right? Kubeflow lecture is already available. So you can say implemented end-to-end pipeline orchestration using Kubeflow. Once again, Kubeflow is a highly rated keyword. So make sure you have something related to Kubeflow in your resume. And finally, you can say strong understanding of real-world MLOps responsibilities. I developed a strong understanding of real-world MLOps responsibilities, including the deployment safety, infrastructure automation, and scalability. So this is how you can make your profile MLOps engineer profile. Very simple, right? So here, this person was a DevOps engineer. By adding these points, this person can show experience as MLOps engineer. Of course, during the interviews, interviewers will ask you the questions. So that is the reason why you learned MLOps through our course, and you have also practiced things from our course. So you don't have to worry. I'm sure first few interviews will be difficult because you might find new terminology in the interviews. You might find some intimidating questions in the interview, but that is how it works. It takes 10 to 15 interviews at least for you to get comfortable. And then trust me, with the experience that you got from this course, you will be able to crack MLOps roles. So stay confident and prepare your resume well. This is a sample resume. I'll share these points within the Udemy course section, even if you are a fresher. Again, freshers have this question. Abhishek, you explained this for the experienced candidates. What about freshers? It's even simple, right? If you're a fresher, you just have this section in your resume. That's all. And you can say, you learned this from our Udemy course. You can show the Udemy course certificate in your achievement section. Because as a fresher, it's totally fine if you tell the interviewers that you learned this course from Udemy, you completed the course, then you implemented it. Make sure you add your GitHub profile. So this is how it works. I hope it is clear to you how to show your experience as MLOps engineer in the resume.